This video will discuss numerical measures of central tendency. We'll describe quantitative data sets by calculating the mean, the median, and the mode. Numerical descriptive measures are going to include the mean, the median, and the mode, and central tendency is the tendency of data to cluster or center about certain numerical values. The variability of the data is the spread of the data. The measures of central tendency include the mean, which we call the average, median, and mode. The mean is the sum of the measurements divided by the number of measurements contained in the data set. So the mean of a sample is also known as the average of the measurements. The symbols that we're using for the sample mean and population mean are as follows. The sample mean is represented by x bar. The population mean is represented by mu. In this lesson, we are concentrating with samples, so we'll be using x bar. The formula for a sample mean, or x bar, is simply the sum of your measurements divided by n, which represents the number of measurements. This is the formula that we'll be using to calculate our sample mean. The median is the middle number when the measurements are arranged in ascending or descending order. So if there is an odd number of measurements, it will be easy to find the middle value. If you have an even number of measurements, you'll have to add those two measurements and divide by 2. Calculating a sample median will be represented by capital M. Skewness occurs when one tail of the distribution has more extreme observations than the other tail. For example, if one measurement is much smaller than the rest of the measurements, that smaller value will bring the tail closer to the smaller end, stretching it out, and then you will see how the tail is much longer on the left side of the data, so it will be skewed left. In contrast, if you have one measurement much larger than the rest of the data measurements, the tail of your mound shape now is going to be dragged out to the right towards the larger values, and therefore you will see a longer tail on the right, and that means skewed right. Detecting skewness by comparing mean and median, we will compare the mean to the median to decide whether skewness is to the left, to the right, or if we have a symmetrical mound. The mode is the measurement that occurs most frequently in the data set. If all measurements occur at the same rate, then we will have no mode. It is possible to have more than one mode. The modal class is simply the measurement class containing the largest relative frequency, or the class with the highest frequency. So let's look at our first example. We're going to describe how the mean compares with the median for a distribution as follows. So if we have an example of skewed to the left, we'll have a picture that looks something like this. So you can see that the tail on the left side of the mound is much longer than the tail on the right side of the mound. So this is what skewed to the left would look like. Now we'll look at this given data set and make a dot plot. Draw a smooth curve over it and see if it looks like it's skewed to the left. Looking at the data set, our smallest value is 2 and our largest value is 20, so I'll count by 2's, and now I'll plot a dot for each data value. Now that all the dots are plotted, I will try to draw a smooth curve. And we can see that our smooth curve over the observations resembles the shape of skewed to the left. So that's just looking at a picture. We can actually calculate the mean and the median and compare those numerical values to prove that our data or the measurements are skewed to the left. This means the mean should be less than the median. So let's work that out. First, we'll calculate the mean. To calculate the mean of our measurements, we'll add all of our measurements from 2 to 20, and the sum of the measurements is equal to 160. For the number of measurements, we simply count, and we have 11 measurements. To calculate the mean, 160 divided by 11, which equals 14.5455. And we could round that off to 14.5 to the nearest tenth. The next thing we'll need to figure out is the median of the data. So we'll go back up to our measurements to find the median. Since we have our values already in order from smallest to largest, we can eliminate the smallest and the largest, and then keep working our way inward. The next smallest and largest. And since we had an odd number of measurements, we would expect just one number to be remaining in the middle, and that's 17. Now that we know the median is equal to 17 and the mean is equal to about 14.5, we can make a comparison of the mean and the median and see if in fact the mean is less than the median. So I'm going to just place the values of 14.5 compared with 17, and it does in fact represent 14.5 is smaller than 17. So what this tells us is that our mound shape is skewed to the left. And we've just proven that by comparing the mean and the median. So our next data set, we're going to look at an example of skewed to the right. So we'll draw the smooth curve. Skewed to the right means the longer tail should appear on the right side of the mound. We expect a picture looking like this. So we'll look at our given data set, draw our dot plot, draw a smooth curve over our measurements, and see how it compares to the picture of skewed to the right. Our numbers range from 1 to 30, so I'll count by fives. So we'll plot each data value, and I notice 5 appears 3 times, so I'll stack 3 dots. 12 appears twice, so we'll stack that. And finally 30. Now we'll draw a smooth curve over these measurements, and we can see how the longer tail appears on the right, so we would expect this data set to be skewed to the right. And now we'll calculate the mean and the median, compare them, and see if the mean is greater than the median. Our data set includes the numbers 1, 5, 5, 5, 6, 10, 11, 12, 12, and 30. So the sum of those measurements equals 97. The number of measurements in the data set is 10. So the mean, which we are calling x bar, should be equal to 97 divided by 10, which would be 9.7. Now that we know the mean, we'll go back to the data set to calculate the median, which actually isn't a calculation. We're just going to eliminate smallest and largest values to find the center of the data, eliminating the smallest and largest, and then working our way to the center. You'll notice since we have 10 observations or 10 measurements in the data set, we end up with 2 values in the center. The median will be the sum of 6 plus 10 divided by 2, or 8. So we will compare the values for mean versus median. Our mean is 9.7 compared with 8 for the median. So 9.7 is greater than 8, and that confirms what we talked about earlier, where our skew to the right means the tail is longer on the right if the mean is greater than the median. Our next example is symmetric. With symmetrical data, you're not going to have a tail longer on one side than the other. The picture or the mound shape will be symmetrical. So we'll sketch an example of what a symmetrical curve looks like. There's our symmetric mound shape, and we expect the mean to be equal to the median. Let's see if that works out with the given data set. We'll make a dot plot for these measurements. Our numbers range from 4 to 25, so I will count by fives to accommodate all the measurements. 12 appears twice, so we have a stack of 2. 14 appears 4 times. 16 appears twice. And now that we have the measurements plotted, we'll draw a smooth curve over the measurements. Now our mound is not quite as tall as the illustration above, but we are going to calculate the mean and the median and compare those values. The sum of the measurements, we will go back and add all of our measurements, and that is a total of 169. The number of measurements is 12, so to calculate the mean, which we're calling x bar, will be 169 divided by 12, which equals 14.0833, which we would round maybe to 14.08 or 14.1. And now we'll compare that with the median. Going back to our data set, we'll eliminate the smallest and largest values until we find the middle of the data. And since we have 12 measurements, we will expect to find two numbers. Here we have 14 and 14. So it might be obvious that the median is 14, but if we were to calculate the median, we're taking 14 added to 14, dividing by 2, so 28 halves is 14, just like we thought. So we will compare the values of our mean and median, and notice we are comparing 14.08 with 14, and you might think, well, those numbers are very close to each other. They're only off by 8/100ths. So that may be close enough for us to say that, in fact, the mean is equal to the median. Now, in another video, we'll talk about the Chebyshev versus the empirical rule to decide if these values are, in fact, close enough to be considered equal. So we've got three comparisons today. When the mean was less than the median, our mound shape was skewed to the left. When the mean is larger than the median, our mound is skewed to the right. And when the mean is equal to the median, we have a symmetrical mound.